All right, welcome back to CS196. So I'm going to do a couple quick announcements to start lecture. Last Tuesday, we started our project kickoff. So if you guys weren't here on Tuesday, please come talk to me or Rohan after lecture. And for those of you who were here on Tuesday, make sure you keep in touch with your PMs because the start of the projects are always where communication is the most important. So make sure you're in the Discord, talk to your PMs, get everything settled, your meeting times, etc. So that way the projects can go smoothly. So we'll go ahead and start off the lecture.
Guys, so before we start lecture, can you join the Kahoot so that we can get right into that when we do, because we have a lot of stuff to cover today. There's the code. Remember to join with your net ID so we can give you credit for coming to lecture and getting anything correct. Yeah, also for today, because it's an intro to Rust, anyone who's in the top 5 will get extra credit on your overall grade. So make sure you're paying attention because a lot of points available today. 1% of extra credit. All right, 1% of extra credit. Just a reminder, please do net ID when you log in, whoever that person was. Okay, I'm going to give it like another minute because people just walked in. Join the Kahoot, and we're going to get started. Okay, if you're not in the Kahoot, raise your hand. Okay, wait another minute. Half minute. 30 seconds. Alright, is everybody in the Kahoot? If you're not in the Kahoot, raise your hand and we'll wait. Okay, great. Alright. Okay, so welcome to our first lecture in Rust. So Rust is a programming language that we're going to be using for the rest of the semester. Just as a note, you won't have to use this for your project unless you want to, but we're going to teach it to you because it's a really powerful language that you can do a lot with. So firstly, let's start off with what is Rust? So these are all really great examples of Rust, but unfortunately, not what we're working on today. So what are we going to do? We're doing the programming language. We're in a CS class. I'll be honest, guys, I spent a lot of time finding really good pictures of Rust. But okay, what is Rust? So Rust is a multi-paradigm systems programming language. So what do those words mean? Okay, let's go with paradigm first, programming paradigms. So a paradigm is a way of categorizing a programming language based on their features. So you're probably familiar with object-oriented programming. So this is like Java, a lot of other languages use this, but you might not have heard of like declarative programming or functional programming like Haskell. So what multi-paradigm programming means is that Rust doesn't restrict you to a single kind of paradigm. You can program in several different paradigms, and Rust will allow you to do that. Now we have systems programming language. So what is a systems programming language? Well, it's a language used for systems programming. That makes sense. It's in the name. But what does that mean? So systems programming is used for system software. And system software is different from application software because it's not generally for a user to use. It's a platform for other programs to run on. And a key difference with systems programming and application programming is that systems programming languages will focus on performance. A key thing here is we want things to be fast, very safe, and we also want to have easy access to the underlying hardware that we work on. So as you know, your computers run on hardware. If we get access to the hardware easily and directly, we can optimize it. Hey, your question? So the question was, is something LC3? To some extent, yes. We will be reading. It's a high-level language, so LC3 is pretty low-level. Rust is like C++ or Java. It's like a high-level language. But it's similar to C in that you can access low-level systems and mess with the bits and like really optimize your programs. Okay, and Rust focuses on safety. Kind of. So Rust can be used both safely and unsafely. And we don't have to worry about unsafe Rust at the moment, but essentially what that means is with things like, in language like C, C is an unsafe language because you can make an array, so an array is a list of numbers and say it's of length 4. But if you try to read the 5th or 6th or even the 50th element, C will let you do that. Even though you're not allowed to see that in memory, C will let you do things like that, which is very unsafe. So safe Rust will help you not get into any memory errors or type errors like that. So safe Rust from the documentation is the true Rust programming language. So using safe Rust is not going to hinder your programs at all or your applications at all. And safe Rust will still allow you to write high-performance applications without needing to worry about memory safety or type safety. So let me just talk about memory safety and type safety very quickly. I can't go back. Thank you. Move back a slide. All right, cool. So memory safety essentially means what I said before, like only accessing memory that you've allocated or that you're allowed to use. And type safety is, let's say I have a character that's one byte in size. If I give it an integer, which is 4 bytes, I have something called overflow, and you can do a lot of bad things if you have overflow. So Rust will protect you from those kind of things. Sorry, safe Rust will protect you from those kind of issues. And the key feature of Rust is safe concurrency. So what is concurrency? Concurrency is a really, really powerful tool that you can use in an application to process multiple tasks at once. And this makes highly efficient applications. So concurrency is very complex, and we're not going to go super in-depth into it, but we definitely will touch on it because it's a key feature of Rust and something that can make your apps very, very powerful. And syntactically, Rust is similar to C++, but it's safer while maintaining high performance. So if you've ever written in C++ or similar to Java, you'll see a lot of features like that in Rust, but it's safer. So you won't have to worry about memory errors and things like that as much. And Rust has been voted the most loved programming language in the Stack Overflow Developer Survey since 2016. So we're not teaching you a totally random language. Rust is used a lot, and I'm going to talk about that in a sec. So is Rust used anywhere? Well, yes, Rust is used a lot, actually. So several parts of the core file system in Dropbox are written in Rust because it's highly efficient and very safe. Yelp developed a real-time A/B testing framework in which Rust is used, and that's used all over Yelp for their web applications, their mobile apps, etc. And Mozilla's parallel web processor engine Servo is also written in Rust because of the concurrency, easy and safe concurrency. So the basics. First and foremost, the documentation for Rust is your go-to for any issues that you have. It's incredibly well documented, and it'll teach you everything you need to know about Rust. Like, I taught myself Rust purely through the documentation. A great thing about the Rust documentation as well is that it has a lot of code snippets that you can run inside the documentation. So if you have any questions about Rust, know that the documentation is the first place to go. Please, if you learn anything from today, learn that, because that's the most useful thing. And the compiler is also a really great tool because unlike other languages, which gives you very arbitrary error messages, the compiler in Rust is very useful and smart and will tell you quite specifically what the issues are. So your first program, set up files and stuff. So if you want to install Rust on your Mac or your Windows or Linux, you can find all the info in the documentation. I'm not going to cover that right now, but it's very self-explanatory. Rust files ends with .rc. So if you make a Rust file, you want it to end at .rc so that your terminal knows what it's working with. To compile a Rust file, you write rustc in the file name and the command line, and this generates what's called an executable. So the compiler will take the code and generate an executable file. And an executable file is a file that can be run. And a key thing to mention is that if there's an error in your code, the compiler cannot make an executable, and it'll instead tell you that there's an error, and then you can debug that and then make the executable. So let's do a very quick recap of what a function is. So a function is a named chunk of code that does a specific job. And an important thing with Rust is that the main function will always run first. So you always have a main function in all your Rust programs, and that's always going to run first. So I'm going to step over here because we will demo this. So this is going to be your first function. It's going to be in main like this. So if you notice here, it says fn. Fn identifies the main function, with main being the function name. And fn tells you that this is a function. You can see that there's parentheses after main. That's where you put parameters into your function. and then the function itself is wrapped in curly braces, like so. So let's go and do that. Let's start off with our main function. So I'm just going to go to my desktop. So the first function program I'm going to write is hello world. So let's make a directory called hello world. And let's make a file. So let's call it hello world.rc. And I'm going to use VS Code just because that's easier to work with than Vim, and it looks nicer. All right, so fn indicates that we have a function. Let's call it main, and do that. All right. So now we're going to do hello world. So we have fn main, but let's do something here. So we're going to use the command println. So that's print line. Notice that there's an exclamation mark after ln. So the exclamation mark shows that we're not using one of our own functions. We're using a Rust macro. So this isn't actually a command or a function. This is a Rust macro, and it's built into Rust. A function call will not use the exclamation mark. So now let's go over here. Let's do println hello world. I keep spelling world wrong. And notice that you have to end all your lines with a semicolon. So that indicates that you're at the end of a line. Okay, let's do rustc. Okay, so now I'm going to list the files here. Now notice we have the file that we made, but we also have this new file here. That's the executable. So on Linux and Mac, to run the executable, we just do /, and then we write in the executable name. So when I hit enter, there we go. Can everyone see that actually? Is that too small? Is that fine? All right. And you can see it printed out this message. There, that's our first Rust program done. So if you look at this, this is a function, a macro call. Inside the parentheses, we pass what's known as an argument. And the argument in this case is a string, hello world, which the macro then processes and prints to the terminal. And this is a small thing that doesn't really matter a whole lot, but in Rust, the styling uses 4 spaces instead of a tab. So if you notice, after fn here, there's 4 spaces here, not a tab. And it might look the same, but that's just what Rust follows. So now I want to talk about cargo. So cargo is Rust's built-in build system and package manager. So why do we need this? Well, sometimes we have very big programs which have a lot of libraries, like imported libraries, which we'll call dependencies. Cargo can do a lot of things, like it'll build your code automatically, it'll download libraries that your program is using, it'll build these libraries. It's a great way to manage very large projects automatically. And that's really good. How do we get cargo? Well, if you followed installation in the documentation, you'll already have cargo installed. So to check your cargo, you just write cargo -- version in your terminal. And if a number appears, then you have cargo. If there's an error message, then you don't have cargo. So let's try that. So if I do cargo -- version, there we go. We have a number here, so we have cargo. We're all good. So how do we create a project in cargo? So all we have to do is write cargo new and then give it a project name. So this will create a directory which will have 3 things inside it. It'll firstly have a source directory, and inside which we'll have our main file, so the file that we write all our code in. We'll also have cargo.toml, and this file is general information on the project details. And finally, it'll also initialize a Git repository and a .gitignore so that we can push our code to Git from inside the current directory. So now we're on our desktop. Let's make our first cargo hello world. So let's go cargo new hello world cargo. All right, so if you look at my desktop now, there's a new directory here. So let's go into that directory. Now let me actually list A. So you can see there's a directory here called source. We have the cargo.toml, and there's also the Git repo here. Any questions so far about cargo? All right. So let's first look at this file here. So as you can see, it has a bunch of information about the project we're working in. So it has the project name, the version, it has the Rust edition, and it even has the author, which is me at the moment. And underneath, you see there's nothing in the dependencies, but if we were importing a lot of different libraries with different tools, there would be more stuff there. And we don't have to touch this file. It's just for us to keep track of what we have at the moment. So now, let's go into the source file. What's really great about Cargo is that it'll automatically give us our first hello world. So let's list the files in source. We have main.rs. So if I do code main.rs, we have our program here. So this is a Rust program. It's very similar to the one we had previously. It's almost identical, actually. And to run this, we can do different things. So let's first go over here. So cargo, hello world. Cargo gives us a hello world function to start off with. So building and running. So Cargo actually handles all the building for you. So if you want to build using Cargo, you just write cargo build in the working directory. So let's try that right now. We can do cargo build. Now what does this do? So if I list the files again, we now have a new directory called target. And in target, we'll have all our executables. So let's go into target and list the files. So right now we have a debug folder. We have debug because we haven't sent Cargo our completed project yet. So if I go into the debug folder, I'll find our executable here, which is right there. So if I do /hello world cargo, it prints hello world. Does that make sense? Okay. So that's how you run it. You can either go directly into the folder and run it, or you can run it from inside the cargo folder by doing this long string over here. And if you don't want to do build and then execute, you can do cargo run in the working directory to compile and run the executable in one line. Cargo also creates a file called cargo.lock, which keeps track of libraries and which in the textbook they refer to as dependencies. And you don't need to worry about this file because Cargo automatically updates it with all your dependencies at the moment. Another command I want to talk about is cargo check. So cargo check will check if your code can compile. So essentially it builds it, but it won't create a new executable. And you're probably wondering, why would I want to use that? Well, if you're writing a lot of Rust code, you want to check if it's working. So one way to do that is by building it, and the compiler will tell you if there's any issues. But to actually build the executable takes a lot of time. So if you just do cargo check, it'll just tell you whether there's any errors without wasting time building the executable. Any questions about cargo so far? Okay. And finally, we can build for release. So what I said before is that if we go into our target folder and list the files, we have a debug directory at the moment. So the debug directory is good because it creates debuggable files. That means Rust will compile files very quickly without optimizing it. If we are done making our file, we can make it for release. So using the command cargo build -- release, it will build a code for release, for production. So the compiler will provide extra optimizations in the target/release folder, and you'll have an executable that's very fast. The issue with using cargo release is that it takes a very long time to compile because the compiler will take time to optimize your code. So we can do that right now. New cargo, let me clear this first. Cargo build -- release. And now you can see there's a release directory here, inside which is another executable with the same name. And obviously, hello world is not going to be much faster because it's a very simple program. But if you're working on a much bigger project, the release version will be much faster. Okay, so now we're going to start talking about actually coding in Rust. So let's talk about variables and mutability. So variables in Rust are immutable by default. So what does immutable mean? An immutable variable means that once you give the variable a value, you can't change it anymore. So the reason Rust does it is to have improved safety and make it easier to do concurrent programs. So let's have an example. So right now we've declared a variable in this code. So in our main we use the keyword let to declare a variable called change_me. And we assign the number 5 to change_me. So we also have this println line here. So the variable has value bracket bracket. So the curly brackets here will be replaced by the variable. Does that make sense? So does anyone want to guess what this code does? Anyone? Okay. Well, the code will say that the variable has value 5. And it'll print that out to your terminal. Pretty straightforward stuff. But let's say we try this now. I'm actually going to do this over here so you guys can see that. So we declare a variable. Let's print this variable out. And now let's change this, the value of this, say 20, and try printing it again. Does anyone want to guess what this will do? Well, if I try to run this or compile this, cargo run, we get an error message. So let's take a look at this error message in detail. So it says, cannot assign twice to immutable variable change me. So as you can see, the compiler is actually very helpful in debugging your code. So because the variable is immutable, we can't change its value. We get an error if we try to. So it also gives us a way to fix this error. We can make this binding mutable. So mutable means that it's a variable that can be changed. So the way we do that is by using the keyword mut, M-U-T. And this will indicate that the variable is mutable and allow us to change its value. And it also indicates to other programmers who look at our code that we're going to change the value of this variable throughout the program. So what will this code do? Well, it's going to print out what we expect. It's going to print out the value 5 and the value 20. Okay, and now I'm going to talk about shadowing. So in Rust, unlike other languages, you can declare a variable with the same name as a previous variable. And we say that the new variable shadows the original variable. So in this code here, we declare the variable var as 10, and we print out the variable here. So now we're going to increment the variable by 1. But we just learned that variables in Rust are immutable. But because we're using the let keyword again, that means we're declaring the variable as a new variable. Therefore, when we run this, we won't get an error. We'll just be able to increment it by 1. So I have this file opened up, or made in advance. So I have this file here. So does anyone have a guess at what this file is going to print out? It's not a trick question. Okay, I'll just run it then. If I do cargo run, we see that it prints out the variable's value 10, 11, and then 5, which makes sense because those are the operations that we did to the variable. So why is this different than using the mut keyword? It's different because we're indicating that we still want to keep an immutable variable. We are making a few transformations to it, but when another programmer looks at our code, we want them to know that this is still immutable and they shouldn't be changing it unless they're doing a transformation like the ones we listed before. And because we're essentially declaring a new variable, we can change its type. If I said change the integer over here to be a string or an emoji, we can do that. It won't throw any errors. So now I want to talk about data types. So all values in Rust are a specific data type. What you might have noticed that when we declare a variable, we don't have to list that beforehand. That's because the Rust compiler is very smart and will infer what the data type is without you having to manually explicitly say that. But having this specific data type lets Rust know how to work with the data that we're giving it. So there are scalar types and compound types. So let's talk about scalar types first. So Rust has 4 primary scalar types. That's integers, floating point numbers, booleans, and characters. So scalar types are variables that hold one value. That's it. Let's start with an integer. So integers are whole numbers. That means they have no decimal part. And we can use signed and unsigned integers here. So this is a diagram to explain how we can declare it. I'll talk more about this in a second. But if we have a bit, if you look at the numbers here, like I8, I16, that number indicates the number of bits we can use to allocate space for that variable. So this is a little confusing, but I'm going to try to explain it here. So if we have IN as the data type, that means we want to have 2 to the n number of bits to allocate for that. So if that's an unsigned bit, that means we'll have 0 to 2 to the n minus 1 numbers available for us. And if we're using a signed bit, we'll have negative 2 to the n minus 1 to 2 to the n minus 1 inclusive. So that is a little confusing. For the most part, you won't have to worry about it because you won't be explicitly labeling your variables, but it's just good to know how this works. And finally, if you use Arch, it'll just give you the number of bits based on your machine. We also have floating point numbers. So floating points are numbers with a decimal part. And Rust has 2 ways to declare a floating point number. You can do F32 or F64. F64 is the default in Rust, and that means you get 64 bits to represent that number. So here's numerical operations, pretty basic stuff, stuff that you use in other languages. One new one to you might be the modulus function. So modulus is essentially the remainder after you do division. So if you do 5 mod 3, the remainder is 2, so you'll get 2 back. We also have Boolean, so Boolean is just true, false, nothing more than that. And when you write true, false, make sure you write it in lowercase. And finally, we have characters. So Rust uses Unicode characters, and you can only hold one of these in a single character variable. We use single quotes to represent a character, and an interesting thing with Rust is that you aren't limited to just ASCII, like numbers, dashes, English alphabet. You can also use Chinese, Japanese, Korean characters, accented characters, and even emojis in what you're assigning to your character. So before I move into compound types, I'm just going to pull up a file that has all the data types we just talked about, and we will share this so you guys will have access to it. So as you can see, there's a bunch of data types here. So here we have our integers. The way we assign the data type is by putting a colon after declaring the variable and then putting the data type in. So this is a unsigned 32-bit. The signed integer is a signed 32-bit, et cetera, et cetera. And as you can see with characters, you can give it letters, numbers. So although this is a number, it's not an integer, it's still a character, and even emojis, because Unicode allows us to have emojis as well as regular numbers and characters. So I'm just going to comment this out so we can run the other stuff. Now we also have compound data types. So Rust has 2 compound data types. Those are tuples and arrays. And compound types can hold multiple values in a single type. So let's talk about that a little bit more. So firstly, we have tuples. So tuples are a compound type which can hold several values in a single variable. So we can create a tuple using a comma-separated list in parentheses. And tuples have a fixed length. That means once we make a tuple, we can make it bigger or smaller. We're stuck with that size. So this is how a tuple looks. So we have the let keyword to declare the tuple, and then we put as many values as we want of as many different types as we want between 2 parentheses separated by commas. And now we have something called destructuring. So if we want to access each of these values individually, we just give it a tuple back. So we create another tuple of the same length, and for each character here, or each value here, we give it a variable name. So that's a little confusing, but let me go to the example here. When I print this out, it's going to print out carvar, which is the first value in tuple 1, and that's the letter A. And when I print out intvar, that's the second value in the tuple, which is 2, and then the third one is floatvar, which is the third value in the tuple, which is this float over here. So if I run that, I hope I'm in the wrong directory. So we'll ignore the bottom stuff there, but we can see that we have the values up here. Oh, where is it? Over here. This is what we wanted to look at. Does that make sense? Any questions about what just came out? What was output? Yeah. Sorry? No, I'm just going to talk about that actually. So we can also use index, like you mentioned. So if we wanted to get the first value, the second value, we can just do the tuple followed by a dot, and then the index number that we want. An important thing to notice is that Rust is 0 index. So we start at 0 and we end at 1 less than the length. So if we want to print out the first value in the tuple, we do tup1.0, as you can see over here. So I'm just going to comment this out and comment this stuff out. And now when I run this, oh, my bad. We see the first value in the tuple is A, which is what the first value is. Does that make sense? Any questions about tuples? All right, let's go on to arrays. So arrays are another compound data type in Rust, and they're very similar to tuples, except they're fixed length like tuples, but they can only hold values with the same data type. And we create an array in a similar way we create a tuple, except we use square brackets, not parentheses. And an important thing is arrays aren't really that useful because they're fixed length, but we'll cover vectors later on, which can grow and shrink in size, and that's much more useful for the projects we'll be working on. So if we want to declare an array, we can do it like this. We say let, give an array name, and then follow it up by whatever we want, a bunch of characters. We can also specify the type and the size beforehand. So similarly, we put a colon after the variable name, and we give it the type and then the size, and then we give it the values we want. And finally, if you want to initialize an array with the same value for every index, you can say the array equals the value that you want, put a semicolon, and then the size. So to demonstrate that, I'm going to run the code over here. Let's comment out the old stuff. All right, so this is the code we just saw previously. Now let's print that out. So array 1 has these values, array 2 has those, and array 3 has 5 cowboy emojis, because that's how we specified over here. Does that make sense? Okay. And to access a specific index in an array, we just do array name, give it a square bracket, give it the index that we want, and then close the square bracket. And again, arrays are 0 index, so if we want the first value, we give it 0, the integer 0. Okay. So in our code over here, if we do this, if we want the 0th value in array 3, it's just going to be a cowboy emoji, as you can see in the output here. Okay. An important thing to note is that if you try and go beyond the bounds, so let's say array 1 we know only has 5 elements in it. If we try to get the 200th index, the code will compile, but we'll get a runtime error. So when the code is running, it'll exit unsuccessfully because it was trying to access memory that it isn't allowed to access. So let's do that over here. Because the previous stuff ran, but now it says thread main panicked because of the index out of bounds. So the compiler is very useful in telling you what the issues are, so make sure you notice compiler errors when you're writing your code. All right, so let's do a Kahoot. Let's start with the Kahoot. If you're not in the Kahoot, raise your hand, and I'll give you guys a minute to join. Oh yeah, also, because the first lecture of Rust, there's a lot of content. If you are in the top 5 in the Kahoot, you get 1 whole % of extra credit. So I hope you were paying attention. Oh, so before we start, any questions about the content? Okay, is everyone in the Kahoot? Raise your hand if you're not in the Kahoot. Okay, 30 seconds. So we're going to start in 5, 4, 3, 2, 1, start. First question should be super easy. If anyone gets this wrong, I'll be really, really upset. The person who got it wrong, please speak to me afterwards. Okay, so this was a little tricky. So I'll go through all these commands. So cargo new creates a new cargo a Rust project. Cargo run will compile, create the executable, and then also run the code. Cargo check will only check if the code can work. So it'll try and compile it, but it will not create the executable. Cargo build, however, will compile the code and create the executable that you can run later on. Are there any questions about that? That was a little hard. Okay, one more question, then we'll go back to the content. Okay, so most of you got that right, but I'll explain the answer. So an immutable variable means that you cannot change the value of the variable. So Rust is by default immutable for variables. Therefore, you cannot change the variable once you assign it a value. So false, you cannot change the value of an immutable variable. Okay, now let's get into some more programming stuff. So control flow. Let's talk about conditionals first of all. So we use conditionals to choose what code we want to run based on current values or whatever's happening in the code. And they're just if statements. Nothing super fancy here. So if statements are written in this form. So we do if some statement, run this code. Otherwise, we do something else. And when you write the condition, you don't need to put parentheses around the statement. The compiler will actually tell you, we'll run the code, but you don't need these parentheses. And statements do not need semicolons at the end. So if you're doing an if statement, you can leave it without a semicolon because the compiler knows this is an if statement. And another thing is you can assign an if statement to a variable. So if you say let var equals if statement, and you put an if statement in there, whatever the result of the if statement is will be put into the variable. So let's look at an if statement because those can be confusing. So this is another cargo file that I made called Conditionals. Okay, let's look at this first one over here. So if we have this if statement, we're assigning this variable to be whatever this number is. The way this condition works is if the first statement is true, and I'm not going to explain that at the moment, we print out the first statement. But if this is not true and this statement is true, we print out the second statement, and if they're all false, we print out the third statement. Does that make sense? Are there any questions about what the code does? Okay, great, because we have a Kahoot about it right now. So what will this code print? I'll zoom in a bit. Actually, no, I'm not going to zoom in. That makes it harder. You guys got 90 seconds because this is harder, and I want you guys to be able to think about it for a little bit. Remember, the percentage is a modulus function, or the remainder. A lot of you guys got it right, so great job for the majority of you. I can explain why the compiler won't throw an error. I don't know why that was selected. But so let's go through what this code does. So To make it easier, let's actually print out what all these statements do. Or we'll talk about it. So modulus is the remainder. So if you divide x by 100 and the remainder is less than 50, we'll do something, et cetera, et cetera. So if we divide x by 100, or if you do mod x over 100, that's an S. If you x mod 100, the answer is 27. Okay, so the first statement, is 27 less than 50 and also greater than 30? Nope, not true. So let's go to the next statement. Is 27 less than 30? Yes, it is true. So we know this is the answer straight away. And we can ignore this final else completely because this else case was never reached. So let's run this. Cargo run. Or is it the second? Second statement was correct. So great job. That was a pretty tricky question, so I'm glad you guys got it right for the most part. Let's talk about more stuff about this. Oh, that's everything about it. Okay. So now we're going to go on to some more stuff about control flow. Now we have loops. So a loop is pretty straightforward. It'll just repeatedly run a section of code over and over again. And the syntax for that is you write loop and put 2 curly brackets without any semicolons. And whatever's in there will keep running forever. And you're probably thinking, well, this is dumb. This is going to crash my computer because it's going to get stuck. And you're right. You can definitely do that. But that's why we have something called the break keyword. And this will allow you to exit the loop. Another thing that's important is that you can assign a value of the loop to a variable. So if you say, let variable equal a loop, whatever value you break with will be whatever is put into your variable. So let me demonstrate that because that is a little confusing. A lot of languages don't let you do that. So let me talk about this code for a second. So we have this mutable counter here, and we have this variable loop var. So we loop repeatedly, and if the counter is less than 0, we break and we return the counter. And we decrement the counter every time. And then finally we'll print out the value of loop var. So does anyone want to guess what this does? Or what the value of loop var will be? Come on, guys. Any guesses? -1. Yeah, exactly. So cargo run. The value of loop var is -1. So does that make sense? How that works? Any questions about the looping? Okay. So we have our demo, and now we have another Kahoot. So I hope that made sense to everyone. This is another tricky one, so take your time with it. Okay, nice. A lot of you guys got this one correct too. So this is another really tricky one. I can walk through the code here for you guys. So I have that down here. So what this loop's doing, we have a mutable counter again, and we have this variable. So we loop through, and if the counter is greater than 25, we return counter times 2. So if we start at 0 and we keep adding 5 to the counter, we're going up in 5 each time. So we have 5, 10, 15, 25. But 25 we aren't going to break here because 25 is not greater than 25. It's equal to it. So in the next loop, when we have 30, we enter this loop here, and we return 30 times 2, which is 60. And if you guys don't believe me, we can do cargo run. Oh, let's clear first, actually. Cargo run. And there we go. Value is 60. So great job. You guys got that right. We'll look at the results at the end. Hopefully we'll have time. So we have 2 more loops I want to go through, and that's the while loop. So you've probably seen this before in Java or Python. If not, I'll explain it. So a while loop will just repeatedly run a section of code while the condition is true. So you say while condition, run the code. Again, you can use a counter, or you can have like a true-false thing going on. What I have here is we say let sumNum equal 5, and while sumNum does not equal 0, we're going to print out its value and then decrease the value by 1. So what this will do is just go through a loop, print out what sumNum is each time, and once sumNum is 0, it's going to break out of the while loop. So we aren't stuck in an infinite loop. And a very dangerous thing with while loops is that if you don't have this break statement or a way to get out of the loop, then you're going to be stuck there forever, and your computer will the program will just crash because you'll use up all the memory that you've allocated it. And now I want to talk about for loops. So a for loop allows you to iterate over a collection of values. And it's a pretty generalized way of talking about it, but I think it's a good way to start thinking about for loops. And as you start using them, you'll realize that it's a little more complex than that. So the loop will run the chunk of code for the length of the collection. So if we have a collection here, and I do for counter in collection, as long as we're still, like let's say we have a list of 1 to 5, I do for counter in collection, we'll go 1, 2, 3, 4, 5, and then we'll stop running this code. So let me go through some actual code to explain what that does. So let's say we have this emoji list over here. Great emoji choices. So for emoji in emoji list.iter, iter just means we're going to iterate through it. We're going to print the value of the emoji. So let's run this and I'll explain the output. So the value is all the emojis in order. So what this code has done is basically it has iterated through this emoji list, and while the emoji is not the end of the list, it's going to keep running this code. Any questions about control flow? Okay. The last thing I want to talk to you about is comments. So comments are lines of text in your code that the compiler will ignore. So you use comments to explain what your code is doing. And that's good for yourself and for other programmers because it's very difficult to look at code on its own and try to understand what it does. So comments are for humans to see what's going on. It's also a good way of like ignoring chunks of code. So you saw me doing that a lot. When I didn't want to run this code, I would comment it out. A comment is just a line that starts with 2 forward slashes. And you can see here, it's a comment, the compiler can't see me. And a cool trick is if you highlight a bunch of code, if you press on a Mac command slash, it'll automatically comment that out. I think for Windows it's control slash. It's a really great way of just, instead of having to go through each line and do slash slash, slash slash like this, saves you a lot of time. Also looks neater. I only learned about this very recently, and I wasted several hours writing the slash slashes in. So that's everything I had to cover today. I know it was a lot of content, so if you have any questions, please post on Piazza or ask us right now, or check the documentation, because that is a great source of information. But yeah, let's look at the results for the Kahoot. Woo. Good job. The Kahoot was really tricky today, so great job, you guys, even if you didn't get on the podium. Yeah, top 5. There we go. Everyone is going to get extra credit here. So great job to all the guys in top 5. Yeah, that's everything for me.
All right, so I'm just going to repeat a couple announcements from the start of the lecture because some of you guys came in late. So if you guys weren't here on Tuesday for the project kickoff, make sure you come talk to me and Rohan. We'll get you caught up. If you were here on Tuesday, stay in touch with your PM, join the Discord, all of that good stuff. Also, we will not be having a homework tomorrow. You guys are free for this week, so get started on your projects, start researching, get to know your team members, etc. And we will hopefully have a Rust homework for you guys on Friday so you can get some application with the material that you learned today and what you'll learn next week. So,
and if you have any questions, just come up here to ask them.
Have a wonderful night.